Alright, so 4.1, number 29, trying to find use analytic methods to find extreme values of function. There's no restricted domain that they give us. Find the derivative. I'm going to use the quotient rule. So that's bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So it's x squared plus 1 minus 2x squared on top. So negative x squared plus 1. So there's my derivative. So we can set the derivative equal to 0. So if it's equal to 0, anytime you have a fraction equal to 0, the only way it could ever be 0 is if the top is 0. So negative x squared plus 1 equals 0. So x equals plus or minus 1. So we have horizontal tangents at 1 and negative 1. So those are two critical points. It's probably going to produce a min or a max at 1 and negative 1. The other time, anything else to consider would be where the derivative is 0 on the bottom. So we can set x squared plus 1 squared equal to 0. So what's going to make the bottom 0? You could take the square root. So x squared plus 1 equals 0. We're going to end up getting non-real answers. So there's no solution there. So there's no point where the derivative is undefined. Derivative exists everywhere. Okay, so 1 and negative 1 are the only potential extrema. So at this point, we would graph the original. And we said negative 1 and 1. I'm going to zoom in a little bit. So it does bottom out at negative 1 and it tops out at positive 1. So we can calculate our values at negative 1. We get negative 1/2. And positive 1/2. So just to look at the sketch, we have an absolute maximum equal to 1/2 at x equals 1, and we have an absolute minimum, that's not absolute, absolute minimum equal to negative 1/2 at x equals negative 1.